going through the scientific method today. So at the end of today, you should be able to describe the steps of the scientific method. So let's talk about our investigation. So let's talk about how scientists learn about the natural world, right? What scientists do is they carry out investigations to explain things in the natural world. They conduct investigations by performing different experiments. Scientists then make observations during those experiments that help them to ask certain questions. They can test the questions with scientific experiments. So what they'll do is they'll run an investigation, they'll see a certain thing, and they're like, this is what I have a question about. This bird is randomly dancing at certain times. I'm going to investigate why, right? I'm going to create a hypothesis. I'm going to create a question that I'm going to try to answer with a scientific experiment. Scientists also conduct experiments to determine if an inference is correct. So sometimes we make inferences about the world around us, right? So we think we know what's going on, or we talk about what's going on, and we're fairly certain it's true. You can run an experiment to make sure that it is true. So guys, fill in your missing words. Your first is investigations. I'm going to highlight these words for you. So our first one is investigations. Our next one, yes, except for first period. By performing experiments is your second one. Then we have observations. So the ones that I'm highlighting are what you're going to write in your notes. Then we have test. And then finally, inference. So these are the ones that you should have filled in. Awesome. All right. After this, now guys, I am going through and editing the actual document. So if you do miss words as I go through, that's fine. You'll be able to go back at the end and find the words that you're missing. Next, we have the scientific method. So if we're using the scientific method to find things out, we need to understand what the scientific method actually is. All right. Hey, Samara, I know that you joined a little late. If you can open up your notes on the assignment today, it's _stu notes _ the scientific method. That would be awesome, because then you can go ahead and fill in anything that you miss filling in. You can go back later. I'm highlighting the correct answers for you. So let's go ahead and talk about this. Let's go ahead and talk about what the scientific method is, right? So scientists use the scientific method to perform experiments. The scientific method is a systematic procedure that directs how to conduct a scientific experiment. So it is a procedure that you follow every single time the same exact way, and that's how we conduct a scientific experiment. You can run an experiment and not follow the scientific method. That's not going to make it a scientific experiment. So you need to follow the scientific method in order for it to be considered scientific. It's in the name, right? The scientific method directs how to test a question, make observations, collect data, and form a conclusion. It's important because it directs how to generate evidence upon which we can build scientific knowledge. So the scientific method is basically a way for us to make a question, test that question, collect data, and form a conclusion. And the reason why this is important is because by using the scientific method and scientific experimentation, we can prove our theories correct or mostly correct so that we can build our scientific knowledge and know that what we are doing is accurate. Okay? So let's go ahead and highlight the words that you need to fill in. The first is scientific method. Yes, speech. Well, maybe don't do it while, yeah, you could do it that way. The next one is scientific method is a systematic procedure. Your next fill-in would be procedure. Then we have how to conduct a scientific experiment. I'm going to be honest with you. I'm making this a lot harder on myself than I should be because I literally printed it out for this exact reason. Okay. The scientific method directs how to test a question. That's your next fill-in. Make observations. So that would be your next fill-in. Collect data and form a conclusion. Your last two fill-ins are evidence and knowledge. All right. So up to this point, if you're following along on the notes, you should, 1, 2, 3, 4, 5. You should have been able to fill out the first 5 bullets of scientific method. We're going to go ahead and do the next one together. So there are 5 steps to our scientific method. First thing you have to do is ask a question. After you've asked a question, you form a hypothesis. Then you perform a controlled experiment. You're going to collect and analyze data from the experiment, and then you're going to form a conclusion. Each of these are your fill-in. I am going to give you a moment to go ahead and write those down. Go ahead and fill out my 5 steps. I'm giving you guys a moment. You can do them. Good morning, wherever we are. So Miss Alex is a student observer, Raylan. She is from a university and she is observing our science class on Mondays. That's why we use the funny link on Monday. So you can, on the notes version, you should be filling in the missing words to show that we're following along. If I'm going a little fast, it's okay. I'm highlighting the answers for you so you can go back. I just want to make sure that we're paying attention while we are going through class. So you can handwrite them. If you want to do them in Kami, you can. I was unable to have them on Google Docs because Google Docs is being funky today. All right, I'm going to go ahead and I'm going to bring us on to step 1 of the scientific method. So the first thing you do in the scientific method is we ask a question. we're going to have an experiment that answers a testable question. So specifically, if we're going to ask a question with the scientific method, we have to be able to test it in some way. So this is a special type of scientific question. So our example is, does fertilizer help plants grow bigger flowers? I can test this because I can plant flowers in fertilizer and flowers without fertilizer and see which one is bigger, right? An example of something that is not a testable question would be, how do rockets work? I can't run a test to figure out how rockets work, right? I can answer that question in another way, but I can't use the scientific method to answer that. So go ahead, your fill-ins are testable. Does fertilizer help plants grow bigger flowers? How do rockets work? I will give you a moment to type those. What? Yeah, I don't know. That's well, walking to the kitchen specifically might be that you're like hungry. All right, guys, let's go ahead and go to our next slide. So step 2 is form a hypothesis. Sorry. I thought I fixed this. Here we go. So when we form a hypothesis, there's a specific way we do this. So what a hypothesis is an educated guess or prediction of the answer to the question. So this is a thoughtful answer to a testable question, right? So with our example of fertilizer having plants grow bigger, if our question is, does fertilizer, right, make plants grow bigger, or does fertilizer help plants grow bigger flowers? Then our hypothesis would be fertilizer helps plants grow bigger flowers. It is the answer, or it does not, right? That is something that we can go ahead and test. A hypothesis is based on observations, facts, evidence, and or findings from previous experiments. So we kind of build our hypothesis based on knowledge that we have from other things that we or other people have done, right? And then finally, we test a hypothesis with an experiment to prove that our hypothesis is true or false, whether we are correct or incorrect. So go ahead, finish filling in your fill-ins. Yes, my darling. Okay, that's smart. All right. That's okay. I'm still giving you time. So I'm apologizing, guys. I did previously go through and highlight these, but again, Google is having a senior day. So I'm just going ahead, and while you guys are filling in, I am highlighting the next slide. Okay. All right, my friends. Let's go ahead and go to the next one. All right, so let's look at step 3. So in step 3, we perform a controlled experiment. A controlled experiment is an experiment in which only one variable is changed. So there are a lot of different variables that can be involved during an experiment. We're only changing one. So what we usually do is we have a control and a variable. So first, let us figure out what a variable is. A variable is a factor or condition in an experiment. So talking about our example with the fertilizer, the variable that we would use in the fertilizer example would be one plant would not have fertilizer. It would just be in regular dirt. That's our control. And the other one would have fertilizer. We would do everything else exactly the same. They'd get the same amount of sunlight. They'd get the same amount of water at the same times. And the reason that we do this is because we want to make sure that the only effect that we're seeing is the variable change, because we have one with fertilizer and one without. So in a controlled experiment, you measure the effects of changing this variable. So you would have to go ahead every day, maybe measure the difference between the two plants. That would be the data that you would be taking. All other variables in our experiments are kept constant or the same, right? So again, it would get the same amount of sunlight. It would get the same amount of water, the same amount of water at the same time every day, right? So these are things that we're controlling. They're staying the same between both versions of our experiment. Controlling variables is important because you want to make sure nothing else is causing changes in the variable you are measuring. So for example, using our fertilizer example, if we were to have one plant without fertilizer, one plant with fertilizer, and then on top of that, give one plant more water than the other, that might also impact how we are seeing the size of those flowers grow and change. Yes. Because it's also giving you important words, right? So you don't have to fill that in, but this is the idea, right? They're constant because we're controlling the variables that we're not testing. Oh, is it? I will fill it in. I just missed it. Nope, you're right. It's probably a fill-in. All right. All right. I will give you one moment. I'm going to start on the next one. Well, if you catch it, you could go ahead and fill it in on yours. I will go back at the end and make sure I've missed everything. It's really sad when I do all of this work and then Google is a butt. All right. All right, so let's start thinking about the next step of our process. So step 4, I'm getting there. There we go. Step 4 is collect and analyze data. So when we collect and analyze data, this is an important part because this is how we draw our conclusion later on. What data is information that is collected during an investigation. So what we do during an investigation is we make observations with our senses. So what do you see, hear, smell, feel, etc.? If you're doing like a taste, you can taste it. And you also so that might be part of the experiment, but the data you collect would be using your senses and measurements, right? So measurements are taken with tools with things like thermometers, rulers, scales, right? With our fertilizer example, we would use a ruler because the fertilizer example is saying that the flowers will be bigger with fertilizer than it would be without. So we want to measure the size of the flowers on each plant as they grow. So the best way for us to collect data is with a data table. So what a data table is it's basically giving you information on the day, information on the data that you took. So if you're measuring with a ruler and any other information. You guys have probably all seen data tables in math at some point when we're talking about graphing, right? Data tables are something that we learn about in math along with graphing. And the reason why it's important is because we take the information from a data table and we then use graphs to visualize the data. It's a lot easier for us as humans to break down what we are visually seeing than just look at a random assortment of numbers, right? So graphs make it easier for us to analyze and interpret data. Here is an example on our side. We have number of rainy days for a location in Virginia. So my data table in this case would have the month and the number of days on it. And then for each month, we would mark the number of days that it rained, right? I could give you a data table that lists 8, 10, 9, 8, 7, 5, but it's easier for us to look at this and we can easily say now, oh, look, April had the most number of rainy days. August had the least number of rainy days, right? March and June had the same number of days. It's easier for us to break down visual representations. So what we do is we create a data table, and then from the data table, we go ahead and we create a graph. So this is where math and science interact. The last thing that we do, guys, is we form a conclusion. A conclusion is the end of an experiment. So what we do at the end of the experiment is we wrap up all of our ideas and we come to our conclusion. So it wraps up and summarizes the findings. So if you guys, I don't know if anyone in this group has done it with me, but if you guys have ever done a lab report with me, this is what a lab report is. I don't think we've done it this year. So a lab report, if you're ever doing a lab, it's essentially a form of a scientific experiment, right? So a lab report breaks down what you did in the lab and the conclusion that you came to at the end. That's kind of what you do here in the scientific method. The conclusion provides an answer to the question. So it says, yes, my hypothesis was correct, or no, it was not, right? It discusses whether the results support or refute your hypothesis. So if we're going back to our original example of, sorry, my brain is functioning. Does fertilizer help plants grow bigger flowers, right? We said our hypothesis was fertilizer does help plants grow bigger flowers. At the conclusion, we would answer the question, yes or no, right? So let's say we do the experiment, we run all the data, and the answer is yes. Right? So does fertilizer help plants grow bigger flowers? Our hypothesis would be fertilizer will help plants grow bigger flowers. Our conclusion, we would state, after conducting our experiment, we have proven that yes, fertilizer does help plants grow bigger flowers. Right? This supports the hypothesis that we made at the beginning of the experiment. The conclusion also explains mistakes in the experiment, right? And suggests how the experiment could have been performed better. So there is this thing called human error, right? So let's say one day you forgot to water the plants at the same time. you started watering, you watered one plant, and then you got drawn away and you watered the other plant at a different time, or the amount of water that you watered wasn't the same, you would include that in the conclusion. You would say, on March 10th, both plants were not watered at the same time. The plant with the fertilizer was watered first. The plant with the dirt was watered 5 minutes later. You could also then say on March 12th, the fertilized water or the fertilizer plant was not watered. Water was skipped on accident, right? You would include that in the conclusion so that people know, like, listen, human error is a thing. These are the things that I did that might have skewed this one way or another. And here's a way that I think that we can do this better in the future. This last piece is super important. How the experiment could be performed better. Because when we're looking at hypotheses in science in general, in the scientific community, we cannot say that something is true or not until it is what we call peer reviewed. So multiple people need to do that experiment the same way or improved upon your version in order to say that yes, this is accurate, or no, this is not accurate, right? So making these suggestions in the conclusion would help somebody who later on might want to conduct the same experiment as you. And do you have a question, my darling? No, you just were using your hand. Yeah, science is kind of like our basis for logical understanding of things. Some problems that we see nowadays, right, is people are using the scientific method, but maybe they're only running an experiment once. So a great example of this is chocolate, right? There are some experiments out there that will tell you that chocolate will help lower your cholesterol or will help you do, if you have chocolate once a day, it will help your blood flow, or like there's like a bunch of like silly things around chocolate, right? Also for adults, they have a lot of things on like wine. Wine and chocolate for some reason are like the two big ones that the media always gets. And the problem is drink the wine, yeah. So the problem with this is there's two issues. One, a lot of these studies aren't being peer reviewed. So one day you'll have a study coming out that's saying that chocolate is good for your cholesterol. And then another study, which is not done the same way, will come out saying that it's actually bad for your cholesterol. And because you have these two studies that weren't a peer review of each other, we don't have a real conclusion about the correct answer. So peer reviewing is important because the more people that run an experiment and get the same conclusion, the more credible or reliable that hypothesis is, right? Or that theory is. And eventually, that's how we get scientific theory. And eventually, we move on to scientific fact, right? A lot of the things that we might consider as fact within the scientific community is because we have a lot of these peer-reviewed evidence that supports it. However, science is always changing. And so because of that, in the future, what we kind of think of as a fact could change, right? Because we are presented with new information and new experiments that change what we previously thought. The second problem is, especially with the media, is that what the media will do is on like real scientific methods, scientific experiments, these papers are like hundreds of pages long. So what they do is at the beginning, they have something called an abstract, which is a summary of the entire document. And media people will just kind of take an overview of the abstract. So they'll summarize the summary and they don't get all the information correct. And so that they're actually reporting is false information that wasn't what the study said. And so that's why we have a lot of people who don't have as much faith in science, because we have people on TV saying all of this contradicting information. Ray, Lynn. We still have 30 minutes left, okay? But we are coming to an end, all right? So this is kind of an overview of the scientific method. Why are we learning this? Who thinks they know? Who thinks they know why we're learning this? Anybody anywhere? No guesses? We are learning this, my friends, because we are going to be ourselves having a science fair for Yale School. We did this last year. We did a virtual science fair, but it was not mandatory. This year, it is mandatory for all students to participate. It is also mandatory means we have to do it. It is also going to be mandatory that all 8th graders must do this project independently. So because my lovely 8th graders, you are in 8th grade, you are going to do this independently. Previous other grade levels might be doing small groups, but we are each going to do our own scientific study, our own science fair project. So what we're going to do this week is we're going to build a lot of background information so that we can feel confident when we do go ahead to start our experiment. And the remainder of this month, we're going to work on actually conducting our experiments and creating our presentation for this, which will be in May. They're going to have this, okay? So the reason why I'm teaching this to you right now is because we're going to be doing this later so that you guys can kind of be ready to do this. So what I want you guys to do now, it is 12:29. So let's go ahead and pull back up our bell ringer.